lines. Chapter 2 is all about parallel lines and kind of the properties that go along with them, the angles that it can be created, and things like that. So first, we got to define what a parallel line is. So I think hopefully you guys understand what a parallel line is. All right, they're just lines that don't intersect. I will say that this is our symbol down here. That is what we use to indicate that lines are parallel. So just be aware of that. You're going to see problems when they say this line's parallel to this line. Just be aware. Okay, so that's the symbol, the shorthand symbol we use. All right, so next is parallel planes. Okay, parallel planes is the same thing. Planes that do not intersect. Again, we still use the same symbol for that. Skew lines. This is something that people kind of have difficulty with, and I think it's one of those things that's challenging until you get it. So they're non-coplanar lines, so they're not on the same plane. Okay, but they're lines that don't intersect. So I think the one that I think about is something like, it's the last example here. It's PT and QR. I think this is the best way to see it. If I extend this PT line right here, okay, and it's on, if you kind of look at it, it's on the front right, okay, and then I'm looking at like QR, okay, QR. You got to remember that this is in 3 dimensions. So for this one, these lines are separated, so they are apart. So one line is going up like this, the other one's going like this, okay? And so they are separated, and they are not ever going to touch because they're on different planes, and they are like, one is like in front or behind the other. That's what I kind of think about. So if you think about any three-dimensional object you have, there's going to be a line that's kind of going up and down, and there's one going to be in the back that's going the opposite way. They're separated. They're separated because they're on different planes. So any of these lines, like we have TW and UQ. TW's up here, and then UQ is right here, okay? And even though, like, if you draw them two-dimensionally, you kind of think, you're like, well, they're going to intersect. But that's just because we're looking at it on a piece of paper. Again, if you think about it, and I can kind of show you this in class if you really have questions. When you're thinking about a three-dimensional object, one's going to be behind or next to the other one so much that it's not going to be able to intersect it. And the last one is PS and VR. So PS is down here and VR is right here. All right, and this is where a lot of times with skew lines, you're going to see lines that go vertical and then a line that goes horizontal. Okay, so that's just kind of like a little cheat there, I guess. But these lines are never going to intersect. So they're similar to parallel lines in that they're not going to intersect, but unlike parallel lines, they don't have the same like slope or anything like that. So they don't have the same properties. All right. And also parallel lines, the important thing is they're coplanar. Skew lines are non-coplanar. Okay. So the next thing I want to talk about is vertical angles and all these other angle relationships. Okay. So the first one's vertical angles. These are angles that are across from each other, and they're going to be congruent. So if you look at this 1 and 2, they're congruent. Okay, they're across from each other. This is something we're going to use for the rest of the year. Okay, and how I kind of think about this is some people say like it's like kissing fish. Okay, if you can extend the lines like this, it's like these two fish are kissing, and that's where we get those vertical angles from. Okay. So there's also angle 3 and 4. They're congruent. And again, if I kind of just extend it out, I have these kiss and fish. All right. And they're going to be congruent angles. So next I want to go over is, close that out, is adjacent and linear pair. Okay. So if we start with adjacent just means next to. Okay, it's just an old word that we use. Okay, like your grandma probably calls things adjacent. Mine grandma does. She's like, oh yeah, that's adjacent to this. So it's just an older word that we don't use too much, so it's not in our vocabulary, but it just means next to. So angle 1 and 2 are just next to each other. All right, that's it. There's no properties. They're not congruent. Okay, we don't know that. They're not, they don't add up to a certain number. They're just next to each other. It's a way to describe where the angles are at. Okay, so they're going to share that common ray. in between them. That's how you know they're adjacent. They share that common ray. All right, next is going to be linear pair. So linear pair are adjacent, all right, and supplementary, okay? Adjacent and supplementary. So, give me a second, yes. Sorry about that. Announcement came on. But so for linear pair, they're adjacent supplementary. Supplementary means they just add up to 180. So if you notice, 1 and 2, they share that common ray, all right? And then they are on a straight line. Okay, this is very important. This is something we're going to see a lot. So angles, so a straight angle, hopefully we know any straight line or straight angle is going to be 180 degrees. So if we just draw another ray and separate that out and create two angles, we know those two angles are going to add up to 180, all right? And they're going to be a linear pair. So that's where if we say, hey, this one is 130 degrees, then we know that angle 2 has to be 50 degrees, all right? And how did we find that? Well, we just did 180 minus 30. That's a simple way. Now, you also might see a problem where you have, 3x and 10x minus 2 or something like this, all right? This is where you have to use the definition down here, all right? And you would just add these two and say, all right, I'm just going to do 3x plus 10x minus 2 equals 180, okay? So and you'd solve that equation. So just be aware of that. If they give you numbers, you can do a quick subtraction problem. If they don't, you have to add those expressions. All right, so the last one I want to talk about, and the one I've kind of already talked about a little bit, is supplementary. So two angles whose sum is 180 is supplementary. So sum just means addition. This example they have, they're also a linear pair. But supplementary angles could just be like this angle here, okay, that, is 20 degrees, okay? And then this one over here is 160, all right? 160 degrees. So, and that, they're supplementary. So supplementary just means they add up to 180, but their location isn't specified. With linear pair, the location is specified because they're next to each other. And then the last one is complementary. Their sum is 90 degrees. All right. So you're going to see the right angle, and then you're going to see that ray that splits them. Okay. And they're just going to add up to 90 degrees. Okay. All right, guys. So let's close out of this. So the next thing I want to talk about is in Savvis, and hopefully I've told you this, the Savvis is no longer homework. It's just extra assistance for you if you're struggling. So you do not have to do any of these Savvis problems, all right, for a grade, okay? But I want this to be in there so that you guys can access this. So there's a concept summary here because this is what we're going to talk about next. So we have those introductory terms, but this is 2.1. This is the meat of it, okay? So for this, we have with parallel lines, we know what they are. They don't intersect, okay? Now we're going to talk about the relationship of angles that's formed when parallel lines are intersected by a transversal, okay? So transversal is just a line that intersects these parallel lines. Now, on a picture, do you see that these two have those arrows filled in? It just looks like a line, and it has an arrow like that filled in. That is the symbol, okay, if they don't tell you in the problem, that is a symbol that we use to denote that those two lines are parallel. They're never going to intersect, and they're coplanar lines. So for the first one, all right, we have those two parallel lines. They're cut by a transversal, which means they're intersected by the same line. And in this case, the transversal is this line right here. And we have this relationship that is formed by the angles. So angle 1 and angle 2 there, all right, if they're same side, meaning they're on the same side of the transversal. So when we say same side or alternate, we're talking about the transversal, not the parallel line. We're talking about the transversal. And then they're same side interior angles. And I think about, like, if you're a person and you're walking down a hallway, all right, you're inside the hallway. That's what I think about. Are you inside or are you outside the hallway? We're inside. So these angle 1 and angle 2, okay, one, use common sense. They don't look congruent. They're not congruent. They are going to be supplementary, okay? So they're going to add up to 180. So those are same side interior. alternate interior angles, this next one here. All right, alternate interior angles, again, inside of the hallway, all right, that is formed by the parallel lines. And when we say alternate, what we really mean is we mean opposite. Opposite. Sorry, those aren't good P's. So alternate is opposite. So angle 1 and angle 2 are on opposite sides of the transversal. All right, they're on opposite sides. And these angles are actually going to be congruent. Okay, they are going to be congruent. So that's for alternate interior. Okay. Now next we have down here we have corresponding angles. When I think of corresponding, I think of matching. Okay, I think of matching. That's what I think about with corresponding. Because if you look, and we have one angle inside the hallway, we have one angle outside the hallway. But if I, on that dotted line, if I cut that in half, okay, I'm going to have this, okay? I'm going to have this. I'm going to redraw it. I'm going to have these 4 angles. That's angle 1. And then if I redraw it down here, I'm going to have these 4 angles, and I'm going to have angle 2. Do you see how angle 1 and angle 2, they match up? They're in the same location. So corresponding angles just match up, all right? They're in the same location on each set of parallel lines. So that is corresponding. You're just going to want to match those angles up, and they are congruent, okay? Angle 1 and angle 2. The last one is alternate exterior, okay? So that's where exterior means on the outside of the hallway, okay? So the person's on the inside of the hallway, all right? These angles are on the outside. So exterior means outside. Alternate, like we said, means opposite. So angle 1 and angle 2 are on either side of the transversal, okay? And they're on the outside, and they are also congruent. Angle 1 is congruent to angle 2. All right, guys, close that out.